Welcome back, chemistry fans. A little bit apprehensive. Got a really tough lab, and I'm hopeful that it comes through and you can actually see the experience to some measure. So we're going to start with this. This is titration. This is acid and base trying to find neutralization point. So let me share with you my other screen here. And you can start to see sort of what's happening on this scenario. So what we have is a burette, and it is filled with a base, NaOH. It's a weak concentration of it, 0.1 molar. So it doesn't have a whole lot in there, and that's inside of this burette. And it's difficult for you to see how much there is. So let's put it up here and see if you can measure. It's starting at the 0 point. Not that that's important, because I have something called a drop counter that's upside down. I have a drop counter in here, and that's going to help me to count how much of the base that I use with this burette apparatus that I got here. Down below, I've got myself a flask, and it's sitting on top of a spinning plate, a mixing plate, a magnetic stirrer, if you will. And then I'm going to turn that on just a second. Inside of it, there is a magnet to try and keep things spinning. I'm going to pour into it 15 milliliters of 0.25 molar HCl. So that's a little bit stronger than was the base that's up in this burette. So I don't need a whole lot of it. So I've already pre-measured my 15 milliliters, and I'm going to go ahead and I'm going to pour that into my flask. Let's see if I can get it in here. Ooh. So let me move that, and I'm going to pour that in right where you can't see it, but hopefully you catch the idea from some of the sound effects. So now I have inside of this container, I have a little bit, and you can start to see that it is spinning, of acid, and it's reading a pH. Now, what is the pH reading? It's reading at a 1.4. That proves it's an acid. It's below 7. Now, you notice the reading is at 0. That's because I haven't added any base to it. Well, that's what I'm getting ready to do. But before I do that, I'm going to take this little pipette, and I'm going to add just a squirt of something called phenolphthalein. Phenolphthalein is an indicator, so it's going to help us to see whenever we get close to that pH of 7. Okay, so here's how this is going to work. I'm going to try and see if I can get everything in the same screen here, where you can see that we are adding solution, and you can actually see my pH increasing. So what I'm going to do now is I'm going to change over, and I'm going to use a graph. And this will start once I start adding solution to it. And we hope to create a S-curve out of this whole process. So I click the start button, and notice it's spinning. It hasn't done anything because I haven't added anything to it. So here we go. I'm going to turn this on very slightly, and it's going to start hopefully registering some individual drops of base. And so every single time I add a drop of base to it, it's registering with that red dot, and it's on my graph here as well now. So hopefully all of this you'll be able to start to see. What I'm going to do is I'm going to hasten this. I'm going to see if I can get a few more drops per second than what I've got. Make it go a little bit faster. Now it's going a little faster. And my pH, it's not going up very much. And that's okay. So at this point, I don't think it's necessary for you to continue watching this process. You will live it in real time. So I'm going to pause the video, and I will come back once we get close and there's a significant change in the pH. Okay, so I will talk with you again very soon. Take a break. Just a quick check-in here. You can see that the line is slowly starting to go up. We started at 1.2, we're up to 1.5 now is my pH. Okay, now the pH is starting to come up. We're at 2.5. We're starting to see a little bit of an increase in how well it is receptive to that base coming. And you notice the curve, it's starting to take an uptick. It's starting to head upward. And so every little drop is starting to increase it very significantly. So we're about ready to hit that equilibrium point. It won't take much more before this flies straight up and creates that S curve. And you start to see the color now is actually also showing signs of some pink. So if we are looking, we're at 4.6, 4.8, we're at 5. We are basically getting to the equilibrium point. Let's see if we can stop it straight at 7 once it hits it. Oh my goodness. Are we going to keep going? Is it going to keep going? I'm going to stop it and see how it goes. If it stops reading. It's going to be really close to that pH 7. Add slow drops so it can catch up. pH can. We shot right past the equilibrium point. I'm going to try and see if I can get it to catch up on the graph now. There it goes. All right. Now we can see what happens with our graph. Whoops, it went to sleep. Let's see if this will finish off our P8 or our S curve now. Looks like it's about ready to start taking the turn towards the horizontal again. You can see there in the top portion, you see how it's turned nice fuchsia pink. It's perfect. And there it goes. There's the top of the curve now starting to form. So it should now just level out on what the pH is. And it appears that we have created the very perfect stereotypical S curve. And I hope that you have appreciation for the delicate nature of what we just accomplished. This is a strong acid into a strong base, and it does make a very perfect S curve, and that's the goal. Now, what we can do from this is we could actually calculate what was the volume at which the equilibrium occurred. We could use some neutralization equations, or we could, if we didn't know what the concentrations were, we could make some calculations associated with that one. But the most important thing is that you're able to establish what that graph looks like, that you're able to capture an image of it. So thank you very much for your time. I will talk with you again soon. Farewell. Goodbye.